much in one day.
Oh, look at that. Hey, it works. Can you guys see my computer screen? Excellent. It's like some kind of karma. Okay, well, we're in good shape then. If we can make this work, we can do anything. What a mess of junk I've got here. Let's see, we're going to go to our bridge guide. So I have received some designs from some of you. I don't know if I've received one from everyone, but I certainly have received some designs, and that's good. I'm going to review kind of what we talked about last time, and then we're going to move on to the next ideas for this project. We started off with our Awesome Bridges activity guide, and these 4 different types of bridges: the suspension bridge and the truss bridge, and the arch suspension bridge and the arch bridge here. And of course, if you've received your building kit, you'll know that you don't have all the parts to build these bridges, that you're going to have to maybe improvise a little bit. That is on purpose. I want it to be that way. I want you to have to not just copy something that is given here, but to use your own engineering abilities and designing abilities, creative mind, to come up with a design. Now, you may have enough materials to do a truss bridge like this. In fact, I would guess that you probably do, and that would be perfectly fine to build one like that if you want to. But I want you to build the best bridge that you can build without going overboard on materials and without going overboard on time or anything like that. Just like any engineer would have to do. Of course, they've given you a list of supplies here. Our list is different. Those supplies that we have available to us are different. And they have some tools here. Definitely you're going to want to use some tools. You're going to want to have those available to you at some point. And they go through the engineering process chart, right? And each one of these steps kind of has its own section in this workbook. So it's a very nice way, I think, to step through this engineering process at the same time. What we were going to try and do is get the first 3 steps of this process done this week by Friday, and then we would begin working on some of the next ones. And so the beginning of this is to make your statement, your problem statement, and your design brief. Then go on and investigate, research different possibilities out there, what's going on in the bridge building world, so on and so forth. Look for resources that you might use, and then to start generating your alternative ideas. And those are the 3 things we wanted you to get started with, culminating in at least one alternative solution that is, drawn up and sent to me for, essentially I'll treat that like a homework assignment. Get that alternative solution into me. I pointed out to you the West Point Bridge Designer software, and it's good software, but you do have to download it and load it onto your system. But I did find another one later in the class yesterday. Maybe I found it in class, maybe I found it after class, I can't remember. But it was at Johns Hopkins University's website, jh.edu, and this bridge designer is completely online. It's essentially a JavaScript thing here. So you do need to have your JavaScript stuff up to date on your computer to use this. And hopefully this one's working. Yeah, it is working. And this is kind of a nice resource for you to use during your design phase of this project. It'll kind of give you an idea of how different kinds of trusses you can build. And it's very likely that you will have trusses in your bridge if you're going to build a bridge like this. So it's so I like it. Anyway, the way that you do this is you add nodes or you add members, and then you can add loads and you can remove nodes and you can remove members and you can remove loads. What are nodes, what are loads, what are members? That's the thing that we have to understand here. And what a node is essentially a connection point between two beams of some kind. So if I add a node here, then I'm just going to click add a node and click down here and it's going to put a little pin joint in there. And then I add another node right here maybe, and I'll make a wonky bridge. We'll put one down here. We'll make a crazy bridge. So anyway, then to add members, you click and drag between nodes and you can connect the dots here, right? This would be the bridge designing university that never gets hired to design bridges. So I'm just going to add in some more members in between these. So you can just start connecting these things. And the idea with trusses, of course, is to make a lot of triangles. Actually, I'm going to leave one out there and do one right here. And so here's my bridge. And you can establish nodes as fixed support nodes. So in other words, if I want this to be fixed to the ground, I click it on the end. So each one of these, I click on and I create a node that is fixed to the ground somewhere. So that one's actually connected to the, it's sitting on the ground somewhere. And you can have a horizontal rolling node. So this one here is sitting on the ground, but it's allowed to roll. It's kind of like on wheels. And that's ideal. You want to have on one side one fixed and one on one side rolling, so that if things start to stretch in the horizontal direction, they can do that. And you can also have a vertical rolling node. So for example, you could have this thing on a vertical wall like that. I'm not going to put it as a horizontal wall. And then if I wanted to add a load to it, I can also do that. I'm going to click on a node here to establish my load. I'm going to drag downward. I'm going to give a 60, I don't know if it's measured in pounds or tons or something like this, but I'm going to give myself a load here. And then you can go ahead and you can click calculate. Right? And here they're telling me I've got members plus 3 must equal twice the number of nodes, members 14, nodes 19. So if I have 14 nodes and 14 members and 9 nodes, I should be able to take 14 plus 3, and it should be twice as many as 9. It's not quite there, right? So what they're telling me is that I'm missing a member, and you should be able to tell where that is, because this should be a triangle here, not a trapezoid of some weird shape, right? So I've added that, and we go ahead and calculate. And it says click anywhere on the grid to calculate the forces. So if I click here, I'm going to get forces in here. The red ones are in tension mode, so they're receiving tension loads, and the blue ones are receiving compression loads. And this is an important thing in bridge design, because here at this 31, you have almost twice as much compression as the 17 tension you have here. And the 40 here is quite high, and the 65 and the 89. I mean, this one's receiving a ton of load, this one as well, and this one up here. And so you can start to see how strong different parts of your bridge should be and how much they're going to bend and stress and everything else. And so it's best to, last time we were talking about using I-beams, it's best if you're going to use I-beams to put them in places that receive a lot of load, that are dealing with a lot of load. Or maybe if you're going to put double beams in, or thicker beams, or whatever, however you're going to do this. So this can be very helpful. Of course, this is a terrible bridge design, but you get the idea on how to use one of these things to build a bridge. Now this one does not have the ability to do things like suspension bridges, whereas I think the other one does. This one is nice if you can't load something on your computer, but if you need to load something on your if you want to do a suspension bridge, then you'll need to load a little more powerful program and have more options building your bridge here. This will also tell you the loads on the end of the bridge here. It's showing here that you have a 34 on this side and a 25 on this side. So this bridge is loaded more on the right than on the left. And that happens with bridges. Some bridges are designed to do that. In particular, I think I showed you the bridge in San Francisco today. The New Bay Bridge. Yeah, I don't think it is. Let's take a look at it. That's the Bay Bridge. The Bay Bridge in San Francisco, the new one that they're building, this is the old one that they're building, that they built many years ago. It's a standard suspension bridge with towers and cables hanging in between, and it's kind of nondescript. It's nothing like the Golden Gate Bridge, which I absolutely love. The color and the span that it spans is beautiful. However, they're replacing the eastern side they've actually replaced the eastern side of this bridge, which is actually a truss bridge, and you can kind of see it in this picture. Let's look at a better daytime picture of this. There's the picture of it where it collapsed. But here's the old bridge. The old bridge is a truss bridge, and you can see the truss design here. It's a little bit of a complex design here, but the rest of the truss bridge is very simple in design. But the new bridge is quite different. They're building a new bridge, or I think they've already built it actually, right next to it. And here's kind of a picture of it. They've got a single tower here, and they've got cables hanging down on either side. The single tower actually supports more of the bridge on one side than the other. On the land side, it's not supporting as much of the bridge, but on the water side, it's supporting a great deal of it. And then out here we have some piers that it's going to go out to. Where's they actually have pictures of it because I think it's down. So this is what it looks like, and you can tell from this elevation drawing of it, you can tell that one side of the bridge is going to have more, it has more length, and so it's going to have more of the load on one side of the bridge. And this shorter end here has less of the load. So it's very interesting engineering design. Just a single tower, well, 4 towers in one actually, and this kind of off-balance bridge. And I think it's one of the coolest bridge designs ever. And this is what it looks like. Here's the picture of the almost finished bridge. You have this single tower here, and you can kind of see the 4 separate towers, and those are actually designed to break apart in an earthquake, for example. And then you have this shorter cable at a steeper angle, and you have this longer cable out here at this much more shallow angle. And notice the support cables are actually kind of interesting as well. The support cables do not necessarily come straight down, they come down at angles. Where on the standard bridges, they come down straight, and that's a very interesting design feature as well. But anyway, you get these kinds of uneven loadings when you have asymmetrical structures, for sure. So going back to our bridge design paper, after you've looked at the resources and done some research, you're actually going to start hashing out, start designing some alternatives, and that's the thing that I wanted you to have turned in today. Of course, once we actually get into this workbook, you have things to fill out. We've got to remember that. We want you to make a problem statement, and you need to change the design brief. I mentioned last time that we're not doing 18 inches, we're doing 24. We're not doing a supporting of 2 pounds, we're doing a supporting of 10 pounds. Again, an argument for using some stronger beams in some places, like I-beams or glued together beams. Sometimes you might need that. The final bridge will be tested until it fails. It can fail if you get a deflection of over ½ an inch, or if you break one of the members of the bridge completely. That's step 1. Step 2 of the process was investigation and research. You want to investigate what you've got to work with, your materials, and also the different types of design out there online and using the bridge designing software. And then step 3 was the generating alternative solutions. We go down to the, notice that The drawing pages have a top view and a side view of the bridge, and you should have that. But you should also follow these kind of guides where you're drawing dots to represent the joints, and you're drawing lines to represent members. And you can use different colors for different types of members. So if you're using an I-beam somewhere, you should either label it or use a different color and have a key to that. Here they're labeling it with C for wire cables, P for plastic connector strips, and if it's no label, they're calling those the wood strips. And so you should have those labeled and make them obvious. You should also have both of these to scale so that your top view and your side view are the same length, and the height and the width have scale representation. And how we do that is to go all the way down to the kind of the end of this page, end of this paper rather, to the page that shows us where we're going to draw the alternative bridge design. And here again the scale is different. 1 square equals 1 centimeter is the scale they gave. We probably want 1 square equal about 1/2 inch, and that will give you room to do a 26-inch long bridge to cover a 24-inch long span. So you need to relabel these and do your bridge design. Fill out this stuff at the top, make sure you've got that in there, and start designing your bridge. I would start off in pencil so you can make eraser marks, or make several copies so you can write it down several times. And each time you're done with a alternative bridge design, you should evaluate the bridge design. You actually may want to wait until all 3 of them are done so that you can evaluate them all together. But you're looking for meeting design constraints. Is it going to actually do the job? The functionality of the bridge, how well is it going to do its job? Aesthetics, how is it going to look? And economy, how well are you using the materials that you've been given? Are you using as few materials as possible, or are you using a lot of materials that you maybe don't necessarily need to use? So, 3 of these in the end. You should have already turned in 1. If you haven't done that, get that done today. And then start working on the other 2 to turn in on Friday by the beginning of class. Now, you've turned in a lot of homework and you've turned in some exams. Everybody's turned in an exam, I think, so far. And now we've turned in our first stuff for our first project. That means it's time for me to start grading. And with these distance learning and online podcast courses, I usually try to wait until about the first exam to grade things, because it takes so long for everything to come in from different places. But I think that I've got a good amount of work from everybody. Make sure that you've got the book work from the first 3 chapters. Make sure, and everything that's been sent to me, I think that I've been able to access at this point. I've been doing a lot of downloading and emailing and converting, so I think I've got some good stuff. And I will get those things, I will get started grading those things, and then I will get a grade report out to you showing you the things that you've turned in, the grades that you've got for them, the things that you're missing. Like I've said before, this class isn't all about punishing you for getting things done on time or not on time or whatever. I want you to do the work. I want you to learn about engineering and to get excited about it. So if there is something that you're missing, just get it done quickly and get it turned in. The next step in this process, after our alternative bridge designs are completed, is to actually make a decision. And that's not all that difficult if you've done a good job with your design, with your alternative bridge designs. So alternative bridge designs finishes up right about here, following all these instructions for drawing good designs. And we get to here, choose the best solution, right? So to choose the best solution, of course, you need to do your analysis of each of these drawings. And I would, again, set them side by side and decide maybe which one is the best looking one, and give that one maybe an 8 or 9 out of 10. And then the next best looking one, maybe, decide it's a lot less, good looking, or it's just a little bit less good looking, maybe give it 1 point less or 2, or maybe even 3 points less. Use a sliding scale that's going to judge these against each other. I don't want you to judge your drawings and your designs against the best bridges in the world. I want you to design 3 ideas and judge them against each other. And then once you feel like you've given a fair judgment on those 3 designs, pick the one that just gets the best score. That's all it comes down to. Of course, they've already weighted this for you so that the design constraints are most important. Does it meet the the project design constraints? Is it going to do what it needs to do? And then go from there. So, once you have decided on which alternative you're going to use, then you need to design this with more detail. And that comes in here in the modeling and prototyping. The first job is the scale drawing of the final design. And if we go to the very end of this thing, past the slide down here, we go past the alternative bridge design sheets, then we get to this page where we have wood member dimensions, where we're actually going to measure out different pieces of wood that we're going to use and write them all down. Plastic member dimensions, all the plastic pieces we're going to use, all the dowels we're going to use, any wires or cables we're going to use, and anything else we would list in those as well. We're going to essentially specify exactly what we need to build this bridge. How long the pieces of wood need to be exactly, how many holes they need to have in them. Every single piece of wood needs to be accounted for in those sheets. Every single piece of wire, and in engineering that is absolutely important. You need to know down to the last screw exactly everything that you're going to use in the engineering project, because you cannot come up short. They will not give you extra money to go out and buy materials. You need to ask for every last penny that you will need, and maybe a little extra, to do a project. Because at the end of the project, if you're short materials, you're going to have to take that into your profits, and that will cost you big time. So you need to account for every little piece of material that you're going to use. Then, and the way that you're going to do that actually is to lay out every single piece on this metric. They call it the metric big bridge layout sheet. They have an A and they have a B, and essentially these two are designed to be sitting next to each other. And then C is a sheet. Let's see, is it the same? It's different. So the A and B have the scale along this bottom here or along the side. Either way you want to think about it, I guess. And then C and D have the scale along the side here. So C and D are essentially your side view, I think. You can use those for your side view, and then A and B you're going to use for your, that's the other way around. A and B you use for your side view, and C and D you use for your top view, I think. I think that's how they do that. I'm not really sure. It doesn't really matter. You can use either one for either one you want, but you want to make sure that you set up the scale correctly. And on these drawings, you're not just going to use a point for a node and a line for a member. You're going to actually draw out each little piece of wood, how wide it should be. So if it's twice as wide as it is, thick, then you need to make sure that is the case, and it's going to be drawn to scale. So you need to make sure the scale is correct. Of course, their scale is in centimeters. We want to do it in fractions of inches. I think that your little 2x4s are about 1/4 of an inch wide by about 1/2 an inch. 1/4 inch deep by about 1/2 an inch wide. So probably each one of these maybe is 1/4 of an inch for your bridge, or maybe each one's 1/2 an inch and you use half of it for 1/4 of an inch, whatever. Whatever works, you need to figure out a scale and use that scale, and usually draw each piece in to scale on these 4 sheets back here. And so that's really kind of the next thing that you're going to do, starting Friday, and hopefully even before Friday, if you're done with your 3 design alternatives, then you can get started on this right away. You can get started putting together a detailed drawing, a detailed paper model, essentially, of your final design, the one that you have chosen for your bridge. And I would like to have that done by Monday. So that's a pretty big deal. So we're going to get all of our alternatives done by Friday, and then we start drawing the final design, the one that we've chosen, get that done by Monday. Because on Monday you need to start building. And we should be mostly built, if not all the way built, by Wednesday, so that we can start testing Wednesday and be done testing Friday. And that is the schedule that we're on. So, we'll talk more about testing and building next week. But that is where we're at with this project so far. We're moving along rather quickly. Now, when we get into making choices about what we're doing here, we need to take some data. We need to take some information down and keep it. So, if we go back to this section on, this is the scale drawing. We go back to the section on, here it is, choosing the best solution. I would keep all three of your alternative solutions with this paperwork, but I would write on one of them final design choice. I would make this decision in big red letters maybe, or something like that. And I would begin taking pictures of things that I'm doing from here on out. If I am maybe I'm testing out how big a hole I can make in one of my 2x4 pieces of wood, and so I drill some holes in different sizes to decide, if I'm going to string some wire or some string through or whatever I'm going to do. And if you start doing some testing, which you might do through here to make decisions on how you're going to specifically build your design, then take pictures of that and include them in this. Just take a picture, print it out on some paper, and put it down here. If you are working out how to string some wire through to make your suspension bridge work out, and you come up with a good idea for it, take a picture of that, or draw a picture of it, or whatever, and include it in here somewhere. You can put in some blank sheets anywhere you want into this to put in the stuff that you have done. But you should be keeping essentially kind of a little journal of the things that you're doing as you go through here. When you get to modeling and prototyping, your journal will kind of be the drawing that you make, and then you'll go on to building. And while you're building, you will take pictures. When you build the road bed, you'll take a picture of it. When you start building trusses over it, you'll take a picture. Or if you're building a suspension bridge tower, you can take a picture of it. And you should include those in. I would expect that every one of these reports, when they're done, should have at least 5 to 10 extra pages of pictures and sketches and drawings of things that you've done while you're doing this project. And that is what we call a logbook. In engineering, when we do a project, we keep a log or a record of the things that we do that are important to the project. And why do we do this? Anybody think of a reason why we want to keep a journal of what we're doing in engineering?
So if something goes fail, you can go back and find it.
So if you screw it up, you can go back and fix it. Exactly. That is one of the biggest reasons to keep a logbook, so that you know what you've done and you don't go back and do the same dumb thing again if it's a dumb thing. Now what's another reason I keep it? It's exactly the opposite, isn't it? If you get it right, you want to go back and say, this is what I did to get it right this time. I got it right, this is how I did it. Now I've known many great engineers that don't keep logbooks, and they generally have a lot of trouble for those two reasons. When they screw up, they're not sure what happened, and when they do well, they can't repeat it. Right? And that's a problem. And another thing related to this is that if somebody else comes along and takes over your project, or they want to come and redo your project, start it again, it's really good for them to not have to reinvent your project, not have to figure out everything from scratch. They can go into your logbook and say, hey, I did this, I see that they've done this, and this, and so I can just start at the end of that process and build from there. Knowing that they had success, or they can verify what you did is correct. And that's extremely important in engineering. You don't want to reinvent the wheel every day. You much prefer to have some information. So start in this, as we get into this part of it where we're designing things specifically, doing specific design on paper with specific parts, specific lengths, and we start to mess around, play around with things, and start testing things and trying things out. If you do something that you think is vital to the project, that is important to your success in the project, make a note of it, make a drawing of it, make a sketch of it, take a picture of it, write down some things, and include this in the book in the proper place where it should be. Has anybody have any questions about the addition of these papers to your logbook or to your workbook here? Okay. Well, just like on Monday, I am going to now end my part of this class. I'm going to stop talking at you, and I'm going to let you go ahead and get started working on these next drawings. I will again leave the system up and running so that if you have any questions for me while you're working, you can ask questions. I will remain in the room, and you have, it looks like, about 20 minutes to do some work on these things and get some more drawings done. Remember, I would like to have the remaining alternative drawings, so 2 more from each person, in addition to the one you sent today, by Friday, the beginning of class. And then by Monday, I would like to have the detailed drawing, which is on the bigger sheets in the back of this workbook, done to scale. And you should also, after you've designed the bridge in more detail, showing how long each member should be, where exactly each node should be, where cables should be strung, and everything else, all the details of your bridge. Once you've completed those details, then I would really like, you really should be filling out the sheets that list all of the parts that you're using, specifically how long each piece of wood should be. So if you're using 5 pieces of 5-inch long wood with 2 holes on the end, then you put that in the sheet. And again, we show you where that comes in. It comes in right after here. So these pages, this is page 17, it looks like, and this one is being used for wood members. And you can have many sheets of this if you need it. But if you had 5. So in this one, they're getting member numbers, so they're actually numbering the parts on the drawing. So they're labeling it on the final drawing, and so maybe they're going to have member number 7 here, and maybe you have 5 of them. So maybe you put 5 pieces, number 7, and then distance between outside joints. If you're going to have holes on each end, you want to know the distance between those, and they want to know the length of this particular member, the length of this piece, and the number of joints, the number of holes in it, and many other, you might have some other details that you write into here. And then you might have another member that you're going to call member A, and you label that on the drawing, and maybe you need 7 of them, so you use 7 pieces, member A, and then the distance, you put in all this information. And if you have other things that you're putting in your bridge, like I-beams, then maybe you need to have a page inserted in here showing how you're going to make the I-beams, how many pieces it's going to use, maybe an actual photograph of making one and putting it together and how it's done. And then you write in here at the bottom, you write I-beams and see page whatever for description, and you talk about the length of the I-beams and where holes might be drilled and everything else, just like normal. So these sheets should be filled out with all of the pieces that you're going to use for your bridge. Every single piece, every single thing that you need to build your bridge should be listed in one of these 3 lists. And if it's not a dowel or a plastic piece or a piece of wood, just put it at the bottom of the list and tell me exactly what it is. And you'll be good to go. We haven't even started building yet, and we've already done a lot of stuff. We've got a lot of work to do. But we will start building soon. Hopefully by Monday we can start building an actual bridge and testing things out and seeing how they're working. So if there are no more questions, I will leave you to it. I am going to go get a drink of water really quick because I'm a little parched, but I will be back momentarily, and I will be available to you. And I'll turn this off so that you can see that I'm here when I come back. I go to let's see what that shows you. It doesn't show you anything. Can you see me there in Maxwell? Okay, so if you can see me, that's good enough. And I'm going to go get a drink, like I said. I'll be back in a few minutes. You guys have 15 minutes to work. Yes. I believe I did. Okay. Okay. Yeah, yes, I received, I'm receiving your emails just fine, so yeah, those are coming through. And sometimes, sometimes it's easiest just to take a picture of your paper with your phone and send, just send that to me in an email, or use the computer to take a picture. I don't know if your computers have cameras on them, but that's sometimes pretty easy to just kind of hold it up and take a picture with the computer and send that in an email. So, yeah, I don't think I opened it, but I can try that really quick, make sure it works. I can see your bridge design. Are you still there, Kevin? Yes. Class students. Okay, I can stop this video now.